So, welcome participants. So, today we are going to cover what is left over from yesterday, and then we will wind up and we will discuss about few remaining aspects. So, just a second till I get something. Okay, so yesterday we were doing parametric tests and we did a lot of parametric tests. Now what we want is non to discuss non-parametric tests also. So again, this is basic statistics nowadays available in even statistics textbooks. I will give you some references also. But briefly, to discuss briefly here, I would say that non-parametric tests are basically tests because that do not make assumption about population parameter. So you must be aware of population parameter and sample mean. So what we are doing throughout the statistics and research methods is that we are using sample data to predict or forecast about the population. Hence, the population mean the population mean is going to help us in sampling and using sample to understand population mean is going to save us a lot of time, lot of effort, lot of cost in terms of everything. So what we are looking at is that when we make this extrapolation or when we make this forecasting based on sample about the population, are we making some assumptions about the behavior of population, or we are not making them? We are not making any assumptions. So parametric tests make certain assumptions. Many of you are aware of such assumptions, but non-parametric tests do not make any assumptions. They are also called assumption-free tests. So, for example, a very common assumption of many parametric tests is that the underlying distribution, underlying probability distribution, underlying sampling distribution is normal, while non-parametric does not make any such assumption. Then many parametric tests, particularly used for comparison, like independent sample t-test or one-way ANOVA, make assumptions of homogeneity of variance. But non-parametric tests do not make such assumptions. Then the typical data that is used in parametric test is ratio or interval scale data, while for non-parametric tests, we can also use categorical data. Then similarly, many when we were yesterday talking about comparison of mean, but non-parametric tests cannot compare mean, they compare medians. And so on, and below in the second half, you can see there are some examples of parametric tests and their non-parametric substitutes. So for example, in correlation, we know Pearson correlation, Carl-Pearson correlation. So there is a Spearman's rank correlation. So Carl-Pearson's correlation assumes normality. It requires ratio or at least interval data. But Spearman's rank correlation, since it is based on rank data, can be applied on ordinal data also. And then for independent sample independent samples t-test, we have a substitute in Mann-Whitney test. Then for one-way ANOVA, we have Kruskal-Wallis. For matched pair test, the paired sample t-test, which we did yesterday. the non-parametric substitute is Wilcoxon test. So in this way, we have non-parametric substitutes available for all major tests. Now, why do we use non-parametric test, or when to use non-parametric test? So please understand that first of all, non-parametric tests are assumption free. They are also used with very limited sample size. That is another feature. So because sample size is also related to normality, I discussed yesterday also that we have central limit theorem for which requires 30 or 50 sample size. After that, you can assume normality for sampling distribution. But what to do if sample size is very less? Then, for example, if you are studying airline industry, so there are very few firms in airline industry. If you take firm level data, similarly in many other spheres, we have very limited sample. So if whenever we are using, and sometimes data sets is not available. So for example, I remember that many people in economics and commerce and business research on FDI. Now, for a long time, FDI data, FDI inflows data was available only on an annual basis, and that too post 1991. Say, if you want to, or you want to study post 1991. So there you have a issue, because now if you're doing the study in 2011, you only have 20 observations, 20 annual observations. So these kind of issues, then there are certain indices also, and certain new series, new indices, new methods of calculation which limit our sample. So for a variety of reasons, sample size can be limited. The It may not be normally distributed, it may not be ratio or interval scale data. So in all these cases, you can use non-parametric tests. But non-parametric tests are not perfect substitutes of parametric tests, and generally are considered only the second choice. So whenever assumptions are met, and whenever there is a possibility that you can fulfill the requirements of parametric tests, you should go for parametric tests. Non-parametric tests, there are several research papers. I'm not going into it. It is the domain of statisticians, because people who do masters and PhD in statistics, they write these kind of papers that they test the validity, they test the rigorousness, they test the robustness of various techniques, they develop techniques, they suggest alternatives. So it is the domain of statisticians. We are just consumers of it. But the overall consensus undoubtedly is that non-parametric tests are slightly, definitely inferior to the parametric tests, and we should not use non-parametric substitutes if we have the possibility of using parametric tests. Now, some of the alternatives I have suggested here. So let us now quickly go back to R and our data sets, and let's employ some of them there. So let me open R Studio. Okay, just a second. Yes, I have been able to open my R Studio. So yes, I think some of these things were not mailed yesterday. So don't worry, we will share with you today. There are also some minor technical issues, so we will sort it out and mail it today. And I also wanted to mail you at one time only, in one go only, after adding some more insights. So I have yesterday added some more things like graphs and all. So we will discuss it today, and then we will be sending over to you. So don't worry, this script file will be available to you. So yesterday We did Wilcoxon sign rank test and found that more or less we got similar results as compared to one sample paired t-test. Now, when we talk about independent sample t-test, so if we again first let's understand what is the role or purpose of or utility of independent sample t-test. So independent sample t-test is used to compare across groups. Compare average value, technically speaking, compare the average value of a scale variable across groups of a categorical variable. And here we can compare across groups of only two categorical variables. Now, categorical variables, when we use them for comparison and when we compare across categorical variables, then look at the possibilities that are there. So if I just begin to tell you collectively, and if we have more than two groups, then we can use one-way ANOVA. And if we have exactly two groups, then we use chi-square. Then we use independent sample t-test. If we have more than two groups, then we use one-way ANOVA. And for both independent sample t-test and one-way ANOVA, we also have non-parametric substitutes. So for independent sample t-test, we have Mann-Whitney test, as I said just now. And for one-way ANOVA, we have Kruskal-Wallis test. Now, let's first understand the context. I'm not focusing on these. We will go through their null hypothesis and probability. That is the statistical part. But we have to focus on what are its business and managerial applications. So if you think of various possibilities. So for example, yesterday we saw data regarding job satisfaction, organizational commitment, and we also saw data regarding employee performance and data regarding these kind of data, attitude towards coworkers and environmental perception. So in these kind of data, it is a huge possibility and a very relevant thing that you can compare this across a categorical variable. So I'm collectively discussing the possibilities. So I'm discussing the possibilities of both cases. That is the case where we have two categories for a variable, or we have more than two categories. So for example, gender, we primarily take male and female, even if we incorporate the other option in the survey, but maybe there is very less chance that we will be able to get a sample. So ultimately we will be left with two categories. Now, so we can compare all of this and try to see if there is a difference. If there is a difference in job satisfaction, organizational commitment, job performance across gender, or across categories of workers, or across, say, employees who have done a training program or have not done a training program, or employees who have, for example, joined from different backgrounds. So for example, in management, we have very diverse audience. So I am sure all of you also must be facing a very mixed crowd. So there are a lot of people from social science disciplines, including management and commerce, and some are from sciences. In fact, IIMs have a huge proportion of engineers in their batch, and they're incentivizing other groups. At one point, there was a survey, and it was revealed that 90% of IIMs class size is male and 90% of them are engineers. So they have taken considerable effort in terms of relaxations to incorporate to have a more diverse classrooms, because more diversity will give more credence to peer learning as well as to exchange of ideas, opinions, brainstorming, solutions to problems in business, society, management. And they have also been incentivizing women's. So now the proportion is slowly changing, not a very drastic change, but depending upon what they use as an incentive, there has been a change in the demographics of their students. But this would be with all of you. You would be seeing that there are, if you're in an undergraduate institution, you would see that after 12th, if you're doing in postgraduate education, you will see that the graduation stream would be diverse for management particularly. So does the performance of students or their placements differ because of this, or their understanding capability in certain subjects differs because of this? That also can be checked. And more importantly, if we look into the other disciplines, like if we look into marketing, so there is a online marketing and online products. So now in the past few months, there was hardly any choice. Many of us did online shopping also, but in the initial phase, online shopping was also closed. E-commerce was also not allowed for non-essential items, and the local shops were also closed. I think both of them opened simultaneously. So there has been a lot of studies, for example, on adoption of or preference for online shopping. So there is a very interesting hypothesis that says that males or men like to shop online while women like to go out and go to the market and see and shop them by themselves. So you can check across in marketing. It is very very useful because marketing, you want to study the behavior of consumers. Consumer behavior is a very very important aspect of marketing, important part of marketing. You are all aware. In that, you want to see whether these demographics like gender, like the place of origin. So, what sells in North India will not sell in Northeast India, will not sell in South India. State to state also, depending upon cultural orientation and other things, it will vary. So ethnic community wise, gender wise, age group wise, the preference would vary. So all this can be incorporated, the consumer preference, consumer taste, consumer behavior, all of this satisfaction, what they like in the product. We in India are such a diverse country. So how do we go about these things? Testing that and testing whether the difference is just due to sample or the difference is statistically significant. If the differences are statistically significant, you can tailor make your marketing strategies according to that. Similarly, in finance, up to last year, there was a lot of discussion about NPA problem in banking sector, and you are all aware that PSU banks are major victims or self-created problem or whatever we can't say things. It is both mismanagement, it is both situations which are beyond control. And so there is huge NPA problem in the banking sector. Now, what if you collect data at say March 31st, 2020? You collect data regarding NPA percentage. And then you have another series like gender in which you ask type of bank. So whether it is a public sector bank, whether it is a private sector bank, we also have a category of foreign banks if you want to segregate in that way. And then you check NPA, capital adequacy, profitability, other things, other ratios. What is the prevalence of it across this, and whether do they differ across these things. So there is so different. Again, if we take certain parameters like penetration of smartphones or automobiles, and we segregate countries, automobiles per thousand, number of vehicles owned per 1,000 people. So again, this is both marketing and economics. And we get the data for countries and we categorize them as developed and developing. Then we can easily check, we can categorize them in multiple regions and see if there is a difference. So in all these cases, we want to check the difference in average score across categories of a categories of another categorical variable. So what I have done here, just to illustrate to you, is that we have, because we took a lot of finance, economics, marketing, and OB, marketing and operations examples yesterday. So now I am talking about HR and OB data. So in the HR and OB data, we have taken JP. JP is job performance and JS is job satisfaction. And you can see that this is again very simple T dot test. HROB data, you can have a very simple name. JP is the dollar, after dollar, it is the variable JP. And we have a title operator in the middle, and then HROB data, and then we have dollar, and then we are using gender. So this sequence you have to remember that whenever we are doing independent sample t-test, then we have to use this title operator, and we have to first write the numeric variable. Job performance is our numeric variable, and then we write our categorical variable like gender. Similarly, does job satisfaction depend on type of employees, that is category of employees? So we are all from teaching community, you are also aware that at many places we have temporary teachers, part-time teachers. So their satisfaction versus full-time teacher satisfaction, is there a material difference? Does it really matter as many people claim it should? So we can see that in this case it is some other industry, but we can think of these kind of studies. And then I have also implemented the same using non-parametric man-Whitney U-test. So I have just provided this. You only, for your users, you only need to change data, and data name you have to give, as I told yesterday, as it is operating, or as it is visible here. The same data type name you have to give, and dollar, the variable name, and you're good to go. Just change it in this and you're good to go. So let us run. So I can run all of this. I just need to select and control plus enter. Okay, again I have to reopen the data. This is SPSS data. So let us try again. Yes. So you have to just import data, because sometimes it takes data from the previous session also, but it is better to import it. So we start with the evaluation from here, I think. Yes. So it is two sample t-test, and the null hypothesis would be that job performance, average job performance of employees does not differ across groups of gender. Average job performance of employees is same across groups of or categories of gender. And you can see the probability value is well above 5 or even 10%. So we cannot reject the null hypothesis. And you can also see that out of 5, the job performance score in this company of both males and females is quite close. And for females, in fact, it is slightly higher. But it is quite close. That is why we are not getting any significant difference. So it is an insight that in our organization, in this organization, job performance does not depend on, job performance does not vary across categories of gender. Similarly, this test has been run using the non-parametric version and the probability is 0.662. Okay, so I think no. Okay, so this is t-test only. You can see this is t-test only. First, they have shown output for both t-tests, and then yes, you can see the data is JS now, JS by type. So we had two types of employees, full-time employees and part-time employees. So the p-value is again very high, 0.662, meaning that indicating that there is no difference, there is no significant difference in job satisfaction across groups, across part-time and full-time employees. And you can see also that their job satisfaction scores are quite similar. Again, there is not much difference. Now, these two tests have also been run by using non-parametric versions. And you can see that in this Wilcoxon test, non-parametric, Mann-Whitney, they give a same name, though it is Mann-Whitney. They are the test has been embedded in the Wilcox test. So don't worry, you are still running the Mann-Whitney U test, but the function that in which it has been incorporated is the same Wilcox test, Wilcox.test, but you are running Mann-Whitney test. So the probability again is very high, similar to the parametric t-test. So there is no difference in average job performance across groups of gender. Similarly, there is no major difference, no significant difference in job satisfaction across groups of types of employee, whether part-time or full-time. And non-parametric tests will definitely give you lesser insights, so that you have to take with non-parametric tests. Now we already understand the context, so let me also run one-way ANOVA now, because the idea is same, but we are now talking about more than two groups. So if I can see what is X1, let me check what is X1 in this data set. And let me also open it again for the new session. Yes, so for this, I had thought of a variable x19. So let's see what is x19. Okay, x19 would be, I am just getting my SPSS dataset ready. There we can see the description. Otherwise, because this dataset has been created in SPSS, otherwise you already have. Okay, so X1 is industry experience. So sorry, customer type. Customer type, it is less than 1 year, 1 to 5 year, or over 5 years. That is what X1 is. So let me open the SPSS data for this. So yes, you can see I have the coding is there in this one. So customer type, whether the customer has been associated with your business for less than 1 year, 1 to 5 years, or more than 5 years. This is what this data set is about. So let's import it. We import this data set, and now the data set is available. So this function will run. And for an ANOVA, we have this function. residual.aov and is the name, general name that we give for outputs related to ANOVA, and AOV is the function. You can see you can easily differentiate between the by through color between the functions and the names that you have given. So you can see the names that you are writing or typing are black, while the functions after you type or select from downward list, they become highlighted because R recognizes them as a statistical function. So AOV is analysis of variance. Analysis of variance. Now we run this, and after we run it, we have to run this also. So we get the summary table. So you can see the summary table for ANOVA has come up. Now, if you see, and X19 also, let's look what is X19. So X1, we understand how long the customer has been associated with our firm, and X19 is satisfaction. So X19 is satisfaction and X1 is our customer type, basically the duration in which as long as they have been associated with us. And remember, these are corporate consumers, corporate clients of our business. So we have run the summary test. Now, if you look at this, then this null hypothesis, you remember this would be 0.0014 zeros, 14 zeros, and then we will get a 2. So this is E minus 16. So this is very, very small fraction after 16 places from decimal. So the null hypothesis is strongly rejected. And again, what is the null hypothesis? Null hypothesis, which we are interested in exploring both in business context as well as in academic research, is that whether the average level of customer satisfaction differs across customer type. So is it different for customers who have been associated with us since long, or is it different, or is it same? So the null hypothesis is that it is same. There is no difference. Null hypothesis always is there is no difference, there is no impact, it is all same. But the null hypothesis, as we can see here, is getting strongly rejected. So we can say that there is a significant difference in customer satisfaction based on their type. That is, how long they have been associated with us. And once this null hypothesis gets rejected, then many of you would be aware that now, since we are comparing more than two groups, so when we were comparing only two groups, so if the null hypothesis got rejected, then we could have easily found out that which group is having a more significance. So for example, if the p-value, if you see here, if for example here the p-value was less than 10% or 5%, then we would have easily said that females average job performance is significantly better than that of male. But here the difference was not significant. But if it was significant, then we would have easily said that females' job performance is significantly better or higher than males. But now what is happening in one-way ANOVA is that we are having three categories, and we don't know that there is a significant difference because the null hypothesis of no difference has been strongly rejected. But now we don't know amongst which two groups there is a significant difference, whether it is between customers who have less than 1 year and more than 1 year, less than 1 year and 1 to 5 year, or is it between customers who have been associated with the business for 1 to 5 years and more than 5 years, or it is between customers who have been associated for more than 5 years versus those who have been associated for less than 1 year. So for this thing, as many of you know, we conduct post hoc analysis. Post hoc analysis in ANOVA. We conduct post hoc analysis to find out exact groups amongst which there is a difference in case our original null hypothesis is rejected. And a very popular post hoc test is Tucky. So we run this test. We are running this because our null hypothesis of equality across all three groups has been rejected. So if I run this, then you can see, let me broaden it a bit. Yes. So you can see here that what is this? It is the difference in average values of our dependent variable, which is X19 or job satisfaction. So it is average job satisfaction of customers who have been associated for less than 1 year minus average job satisfaction of customers who have been associated for between 1 to 5 years. Similarly, it is average job satisfaction for more than 5 years minus average of job satisfaction of those associated for 1 to 5 years. And finally, average job satisfaction of more than 5 years minus average job satisfaction of less than 1 year. And you can see that the difference is negative. So 1 to 5 year, those who have been associated between 1 to 5 years have more customer satisfaction, sorry, not job satisfaction, sorry, customer satisfaction. Customers who have been associated for 1 to 5 years have higher customer satisfaction than customers who have been associated for less than 1 year. And this difference is statistically significant. You can see here. In fact, all three are statistically significant. So this is very, very important insight in marketing. And this is something which the company should actually leverage upon. Company should share this data, analytics data and results with its clients and also promote it to their prospective customers. Because it is very important, because the customers who have been associated with them for the longest duration, they report significantly higher satisfaction level. You can see that also. The difference is highest between customers who have been associated for more than 5 years versus who have been associated for less than 1 year. This difference is highest. Then more than 5 years and 1 to 5 years, again this difference is higher, positive, meaning more than 5 years is also satisfaction of customers for more than 5 years is also more than satisfaction of customers who have been associated for 1 to 5 years. And satisfaction of customers who have been associated for less than 1 year is less than, because you can see the negative sign, less than the satisfaction of customers who have been associated for 1 to 5 years. And all three are coming out to be statistically significant. This is a very valuable insight for the company. Similarly, you can think of various other applications and uses for this. And you can also apply the non-parametric version, Kruskal test. So you can see the red icon here. It is running the analysis. And the results are with you. There also we get the similar result. Now moving ahead further. Now we quickly take up the topics of correlation and regression also. So let me also clear up the console. Now correlation and regression, you all understand. We also advised you to revise it back in advance. So correlation is association between variables, and we are into studying the association between variables. So we want to see whether there is a positive relationship, a negative relationship, or a no relationship. Causality and impact is established through regression, but in fact, a precursor to regression is correlation, because if there is no association between the variables, there is no point of having any causality. Now, to get started with this, a very good idea of correlation can come up with a graph. So let's start with a graph. So we start with a scatter plot. Scatter plot is the best way to see correlation graphically between variables. So I will first illustrate to you scatter plot, and then in the next one I will be telling you about scatter plot matrix. So scatter plot matrix, for example, is not available. Now you see in many advanced and good quality research papers you will see scatter plot matrix, but as you would know, scatter plot matrix is not available as an option in most of the softwares. So most of the standard softwares, but in R, as I said, it is completely flexible, it is completely extendable into incorporating additional things and advanced things. So I will just show you that. So let's do this. So you can see and you see the command is so simple. It will take you, lesser than time on any other software. This is a very simple command. Plot, you have to enter the data, dollar variable, data, dollar variable. Just this. And in between, you have to just put a comma. This is so simple. So let's generate a simple scatter plot which will give us idea. So what I am running for is X19 and X20 of the marketing operations data. So let me tell you what they are. I think X19 is likely, X19 is satisfaction, and okay. Okay, so we are seeing the relationship between satisfaction and likely to recommend, likelihood of recommending. So if customers are, because this is customers data, so if our customers are satisfied, are they really likely to recommend us? And this, because in private sector and corporate world, recommendations are very important, because they look for trusted partners, trusted suppliers, trusted people to do business with. And in that case, they look to engage with those who have already some experience with other reputed other reputed people, other reputed clients in the same industry or same business. So recommendations are very, very important, and they increase in importance particularly for corporate clients when we are talking about business to business marketing. And this is a business to business marketing data. So if customers are satisfied, are they likely to recommend us to their peers and to their other uh, you know other businesses that can use our services? Are they likely to recommend us? So let's see. So all you need to do is to just write this plot, data, and variable, comma, data and variable. And we run this. So you can see, let me enlarge the screen because we had reduced it earlier. So you can see the scatter plot. Now, if change these names X19, X20, you will get different things. I'm not going into that. That is basic stuff. I will tell you how to do those things also in the afterthoughts. But you can see that the shape of the scatter plots, it is like basic thing that we did in schools also. We have the x coordinate and we have the y coordinates, and we plot them as dots. This is a two-dimensional surface. Now you can clearly see an upward trend. And though it is not very strong in the sense that dots are not exactly lying on each other or very close to each other, there is some scatter, but it is definitely an upward thing, maybe a moderately positive correlation. Not a very high, or maybe not even high correlation, high positive correlation, but definitetly moderate, or maybe early part of high, because there are again subjective ways. So some people say that above zero point 0.9 it is very high, above between zero point 0.7 to zero point 0.9 it is high, between zero point 0.4 to zero point 0.7 it is moderate, and below zero point 0.4 some people take say below zero point 0.3 it is low correlation, and similarly on the negative side. And you all understand that it lies between +1 and -1, perfect positive to perfect negative, zero meaning no correlation. So this is the graphical thing, but we definitely have either moderate or high positive correlation between likelihood of our satisfied customers being recommending us to others. And you can see that they are on the same 10-point scale. But scaling does not matter in that sense. It will automatically rescale itself. Now we can see the correlation also later, but let me show the calculation of a scatter plot matrix. So for calculation of a scatter plot matrix, I am using another data which we used yesterday also. I showed you the data. So the data set is financial and economics data, and we want India's I index, which is India's stock index, IGDP, India's GDP, India's inflation, India's interest rate. So the function that we use to generate a scatter plot matrix is pairs, and there is the Tiddler operator, and then we have to use this plus sign. So again, and we can write the data separately like this. Again, this format will be with you. You just have to fill in the gaps with data set and variable name. And if I run this, okay, so I have to import the data once again. Yes, now we should be good to go. Yes, you can see now. Let me expand it to full screen. Yes. Now, these kind of things are there, and how some of the colleagues are asking to do it on, iPads and smartphones. You can see that even this 15.6-inch laptop, if you want powerful computing, powerful analysis, then how will you be able to do it on small screens with limited computers? You have to upgrade yourself according to the requirement. So this is the scatter plot matrix that we have obtained from our software. Now let's see how to interpret it. Now scatter plot matrix, as you can see, has plotted all the bivariate combinations. Now you would ask how we can figure out that which scatter plot is for which combination. So let me use the highlighting tool, spotlight, and show you. So for example, this one, this scatter, this is between I index and IGDP. This scatter is between I inflation and I index. I index I index covers everything in this column. I GDP covers everything in this column. I inflation covers everything in this column, and I interest rate covers everything in this column. And similarly, they also cover everything in their respective rows. So in all the three graphs in the last row, it is interest rate. In all the three graphs in the second last row, third row from top, we have inflation as one of the variables. Here in all three graphs, we have GDP, and here we have index. So this graph, we have I index and I GDP. Then this one is about I index and India's inflation. This one is about India's index and India's interest rate. Then again, this graph is about India's index and India's GDP. This graph is about India's GDP and India's inflation. This graph is again about GDP and interest rate. This graph is about inflation and interest rate. Then we have inflation and GDP here, and inflation and index here. Then interest rate with inflation, interest rate with GDP, and interest rate with stock index. So you can easily see and you can interpret. Now, those who do research in finance know that we have to detrend the time series. I pointed yesterday also. So we have taken only the return or growth rate series here. We have taken the stationary return or stationary growth rate series here. That is why we are not getting very high correlations or very high, clear cut upward pattern. Because if we would have taken that, then it would have been a, almost a perfect correlation, because over time they are moving together. But we have to remove time component through stationarity for time series analysis. And you can see in some cases, for example, between India index and India's GDP, you can see moderate or maybe low positive correlation. There is a slight upward direction. And expectantly, you can see between inflation and interest rate, slightly downward pattern between inflation and interest rate. Again, this is just graphical assessment. You can get the exact values through correlations that we are going to just calculate now. And also, you can see that these are diagonal elements. This is the triangle, this triangle below this triangle comprising of 6 graphs below, and this triangle comprising of 6 graphs above the diagonal are mirror images. So same thing is getting repeated twice. The same 6 graphs, so we can only have 6 graphs among 4 variables, 6 bivariate graphs. So those 6 bivariate graphs are both on the or below the diagonal and above the diagonal. And you can, and as far as copying or pasting is concerned, you see when I right click, you easily have an option of copying this. You can copy it and you can take it to other PPT or Word or whatever you are using for your analysis. So this is how we generate these kind of graphs showing the relationships. Now let's compute things statistically. Let's compute statistically. So we need to compute correlations. Now I have to save time and to also show you the entire spectrum of possibilities. I have written the entire command, and then there we have taken it in a individual manner. So you can see, I hope you can see that okay, so I hope you can see If there is request for increasing the font size again, but that is the problem, if I increase the font size, everything will not fit in the video window. You can see the graph is almost gone, but okay, let's bear with it for a while. Okay, so I have increased further. I have now made it 200%. So, you see that this is the standard, this is the broad equation or broad command, you can say, for running bivariate correlations in R. Why I say broad command? Because you can see it is very simple. It is core.test. Core you can assume stands for correlations dot test dot. You can have simple correlations also. But in research, we want correlation values along with their significance. As you know, in research, we want correlation values along with their statistical significance and probabilities. So we have used core.test function instead of simple core function, which would have only given you the correlation coefficient value. But we want to also test their significance. So core.test, and again, it is very simple, just the data set, dollar variable, comma, since it is bivariate correlation, so data set, dollar variable. Now, there is an argument in this function, which is alternative. So you can see, you can change it between two-sided, less or greater. So actually I have written it in as a text. You can see the hashtag before, because I have we can use only one of them at one time. So, but these, just to illustrate to you, these are the three options available. That is the three options that you can have. Yesterday also we talked about this. So you can either be looking for a positive relationship. So what is the null hypothesis here for correlation tests? As you would assume, as I said also earlier, no correlation, no relationship. So the null hypothesis is that correlation coefficient is equal to 0. Null hypothesis is correlation coefficient is equal to 0. So if we are running two-sided, and if you do not mention anything, it will be two-sided. So if we are running two-sided, or if you do not change the alternative, then we are talking about there being a correlation different from 0. That is, there is some relationship. It is not 0. There is some relationship. If you're looking at negative relationship, like between inflation and interest rate, or interest rate and stock market, then you would be looking for less. So it is a one tail, lower tail test when you put here less. Similarly, if you're looking for positive association, like between GDP, industrial production, and stock market, then you're looking for greater or more than, greater or more than. So it is upper tail test. So this is how you can specify it. And in the method, you can use three. So these are three popular correlation techniques, correlation statistics that are available with us: Pearson, Spearman, and Kendall. Many of you may not have heard about Kendall. So Kendall's tau is also a correlation coefficient like Spearman's rank correlation for ordinal data. Kendall's tau is also a non-parametric measure which can be applied on ordinal and nominal data, but the difference is that Kendall's tau is particularly has been again statistically, and statisticians through their complex mathematical papers and studies have suggested that Kendall's tau is more suitable for small sample sizes, for as a non-parametric test, and for small sample sizes. Spearman is more suitable as a non-parametric test if you have larger sample size, say more than 30. while Pearson is a parametric test which assumes normality, so it can be applied only on metric data, which is non-categorical, and it requires large sample size, otherwise you will face issue with normality because it is an assumption of Pearson. So we can choose, and if the sample size is large enough and you have actual numbers or returns or scale items as your data set, then you don't need to worry and you can directly use Pearson. So this is the broad argument. Now I have run this on two variables. So I have run this on x19 and x20, and x19 and x20 are again, I think, our likelihood, our satisfaction. Just let me quickly check. Yes, satisfaction and likely to recommend. So I have illustrated all this. You can see here I have in one case I have taken a two-sided argument, and we have used Pearson, then we have used a less argument instead of two-sided, you can see, and we have used Kendall, and then we have used a greater argument for upper tail test, and we have used Spearman. And if I run this portion, control plus enter, you can see that the result is being computed, but for Pearson it has been computed, and you can see, as expected, we were talking about this, that the correlation in the earlier scatter, that it might be high or moderate. So you can see that the Pearson correlation is 0.76. So it is in the high category. If you consider 0.7 and above as high, then it is in the high category. And again, you can see the probability is very, very small. So the null hypothesis, which said that the correlation coefficient is 0, is strongly rejected. So there is a significant correlation, and that correlation is positive as expected, as it should be, between customer satisfaction and their likelihood of recommending you to others. So it is positive, it is significant, and it is high also. And you can similarly interpret Kendall's tau. You can see the alternate here is true tau, that is true correlation is less than 0. So this null hypothesis of being correlation being 0 versus this alternative is completely rejected, meaning that alternative is not true. Null, you can see that the p-value of null hypothesis is 1. P-value of null hypothesis is 1. So we cannot reject this. We cannot reject the null hypothesis. So alternative is not at all true. As you can see, why it will be less than 0 when it is 0.76. So there is no chance that there is a negative correlation. So you're understanding what we were testing here, that is there a possibility of negative correlation between customer satisfaction and their likelihood to recommend us? And that is why we used this argument, that it is a lower tail or less than argument, that the correlation is less than 0 or negative. But there is no evidence in its favor. We have a p-value of 1. And for greater than 0, you can again see we have almost similar p-value as to Pearson, and the Spearman's rank correlation rho value is also quite close to Pearson's correlation coefficient. So this is about correlation analysis, and then we come to regression analysis. So we all understand the importance of regression. Regression is the cornerstone technique, and you all understand that regression is used both for assessing the impact and association between variables, as well as for forecasting and prediction, and the number of alterations and modifications of regression. In fact, most of the other techniques that are there, they are essentially some modification or some extension of regression. So whether it is structural equation modeling, whether it is mediation moderation analysis for qualitative and behavioral categorical and sorry, for survey based and behavioral researches, or it is advanced time series models like ARIMA, and other Granger causality and co-integration. So all of them at some level are either modifications or extensions of the fundamental idea of regression. So we have a dependent variable, we have an independent variable, and we look to see whether the independent variable has a significant impact. Independent variable is causing, independent variable is predicting the dependent variable or not. And whenever we take a single independent variable, we call it simple regression. Whenever we take more than one independent variable, we call it multiple regression. Again, you can look into other basics. Now in R, so we will again be focusing on applying it and interpreting it. So in our environment, the way of running a simple regression, is very simple. So we can, write something like fit. Again, we understand this. We created so many variables, and I told you that this is the way of creating variables. And I told you that variables in R are very flexible and very important. And variables do not only hold one data or a set of data or a single series, but they can also hold graphical outputs. They can also hold statistical results of any technique. So this is a variable. So, recall the first 2 days. So some of you were feeling that when we will go to analysis, so analysis can be done in just one line, one command. You have to understand the basics of R. Otherwise, you will face a lot of problem. If your basics are clear, that is why we focused on basics for 2 days. So fit is a variable. We can give any other name. It contains, now what is this? This is LM. LM is linear model. LM is linear model. And what we have used as dependent and independent, and what data set we have used in this analysis. So you can see that we have used staying intention. Again, we have used HROB data, and we have used staying intention as the dependent variable, and we have used job satisfaction. So, intuitively, I am not an expert in HROB, but intuitively it looks that if an employee has a high level of job satisfaction, then they should also have staying intention of continuing with the organization. So we have, but still, we have to check it in research. We have remember my first session and first introductory part, we have to provide evidence along with justification of along with practical justification. So in regression, there has been cases of what is called spurious regression. Spurious regression meaning regression which have no context, no meaning. So for example, if whenever a child is born in a family and you plant a sapling on the same day, then over time, if you measure the height of that plant as well as the height of the child, both of them will be increasing. Now, if you regress the height of the data, you collect the data, note down the measurements at different points, and if you regress the height of the child on the height of the plant, you will get a statistically significant result. Very high R square, very high significance, but it does not make sense. So entire framework of quantitative analysis and that of research is that first you propose something based on the theory, based on the logic or reasoning, and then you collect data and you analyze it and you then justify whether your original hypothesis has been rejected. If yes, then you justify it with further explanation. If not, then you provide reasons for it. So whatever you are proposing, you have to verify it empirically, provide statistical evidence, not only descriptive statistics, you have to conduct significance tests like we have been doing since yesterday. And you have then the argument is complete because you have proposed the argument, you have provided reasons and literature for the argument, as well as you have provided empirical support. So if you want to motivate the management, if say management in an organization is worried about employee turnover and employees leaving the company, and if you think as an HR power manager or as a stakeholder that job satisfaction, or maybe in this data set which we are using, we do not have employee engagement. Otherwise, employee engagement is a very popular, very widely used measure. In fact, many of my colleagues from college and also research scholars that I know, some very close ones, have done good research on employee engagement. That is why I am aware of employee engagement. Otherwise, it is not my area. So we could have also taken employee engagement as a predictor of staying intentions, as well as employee engagement and job satisfaction can also be taken as predictors of organizational commitment, of job performance, and so on. So, but it has to be seen in your respective fields. I'm not an expert on this. So, staying intention, and we have, so please remember LM is the function for running regression. In R, it is shortcut for linear model. First, you have to write the dependent variable, then tiddle and independent variable. This space you can provide, you can ignore also. But as I said earlier also, giving space is a good practice. But this space between before and after this tiddle operator is entirely optional. So dependent variable, tiddle operator, followed by independent variable, and then you have to provide the data which is being used for this analysis. So simply data is equal to this. Then you have to use two more functions along with lm, summary, so it will give you the model summary, and coefficients, so it will provide you the coefficients table. So let me run this for you. So we had already opened the data set in this session also. So there has been no request for reopening the data set, and we have got the results. You can see here. So first there is some statistics about residuals, but if I quickly first look at the model statistics, so you can see R square. R square is quite low, though R square is 4%. Adjusted R square is also very close because we have only have one variable along with intercept. But it is fine because in behavioral research, when we are talking about staying intention, so it will definitely not only depend on job satisfaction. If we run a regression with staying intention, if maybe I can show you now only. If we run this regression again and we add more variables, like we have few more variables in the data set, like attitude towards coworkers and environmental perception, then the R square will be high. But we are not interested in predicting the explaining the entire model, entire staying intention concept. If that is the purpose, you have to add more and more independent variables. But here the purpose is to check whether job satisfaction is a useful intervention to reduce employee turnover. So we are examining the relationship between job satisfaction and SI or the impact of job satisfaction, causal impact of job satisfaction on employees' staying intentions. So you can see that F statistic value is 17.76. These are the degrees of freedom. And again, this value, if we paste it in Excel, you will be able to see its true form, but it is 0.0003111, I think. That is what it would be. So it is definitely less than 5% and all. So our model is fine. And you can see that job satisfaction is also statistically significant because the probability value is less than 0. And in regression, the F statistic is checking the overall significance of the model. The F statistic or ANOVA in regression tests the overall significance. So it talks about the null hypothesis can be put like this for F statistic in regression, that all independent variables taken together are 0. All independent variables collectively are 0. Or it can also be stated like this, that R square is 0. That is, model is useless. Model does not have any explanatory power. So whether it is that R square is 0, or whether this all the independent variables are 0, both of it is getting rejected here. Not very high F, but still reasonable. Because we have taken only one independent variable, so it is getting rejected. So our overall regression model is useful. And in fact, very few of you might be aware that this F statistic value, which is close to 18, also has a direct mathematical implication. So this model that you have specified is about 18 times better, because this F statistic numeric value is 17.76. So it is 17.76 times or 18 times better than a base model in predicting staying intentions. And this independent variable job satisfaction, again, the null hypothesis here is that the estimate or beta coefficient is 0. Beta coefficient is 0. That is, there is no association between in fact, not association. That is, job satisfaction does not have any impact on staying intention. Job satisfaction does not have any impact on staying intention. And again, you can see that it is also getting rejected. And the sign after this, you can see the sign. The sign is also positive. So in correlation also, I usually say this, in correlation also, you should see three things. 3S, I suggest: significance, sign, and size. So significance in correlation we established, then sign is positive, and size. So we say that we have a we have a significantly high positive correlation. Significant because p-value is less than 5 or 10% usual benchmarks. Positive because the sign here was positive. And size high because above 0.7 it is considered high. Similarly, in regression also, for all independent variables, you can comment on the significance. So there is a significant impact of job satisfaction on staying intentions, and that impact is positive because the sign is positive. And this size interpretation will not mean much here, but going by the literal definition, it would mean that one unit or one scale, whatever is the scale, underlying scale, so one change in that for job satisfaction will cause this much change in staying intention. But in behavioral studies, these kind of interpretations are not important because we are not exactly, and in quantitative terms, we cannot measure these job satisfaction, staying intention, all of this. So more important is that we have a significant positive association. Now I plan to run the other model, including which now why do we go beyond this? Why don't we stick with simple regression? Why we use multiple regression? The reasons are twin. First reason is that simple regression is not useful in explaining the dependent variable. As you see, as you saw, that the R square value is very, very less. It is just 4% because you have put only one independent variable. There are many more things that explain it. So if you add more variables, then your explanatory power will increase. So that is one reason. Second reason is that it can also lead to misleading results having only one independent variable. Why? I give you two examples. So first, if you take if a child is born and if you start measuring its IQ and you start measuring its weight, body weight. So especially in the initial years of, and you say collect a monthly data of this. Say you collected for up to 10 years. You collect the data for 10 years and 10 years monthly data. So it would be about 120 observations. So you have 120 values for the IQ level of that child and its body, his or her body weight. Now, if you regress the IQ on body weight, you will get a highly significant, very, very high R square relationship. It would seem we all are interested in improving our IQ, so it would seem that the best way of increasing our IQ is to increase our body weight. And you know that this is not true. Both people who are overweight or underweight, they can be intelligent, they are intelligent, they have a good IQ. IQ has nothing to do with body weight. But this is the result that is you are getting. You know why? Now let me open this up and let me ask the participants. Do you know why this is happening? What are we missing here? Can anybody tell? I give you a hint. There is a third variable related to this child, which we have not incorporated in the regression model. That is why we are getting to this flawed conclusion. So what is the variable that is missing? What else should we put in this regression apart from weight as an independent variable so we can get the correct results? Any suggestions, participants? Please write in the chat. So I'm getting few responses, others also. Asha ma'am, error term will be, the residual thing. For which independent variable we are missing? Yes, Doa ma'am is saying no idea. Okay. Anyone else? Yes, so we are getting age, height as two suggestions. Gender. Okay, is gender relevant here? I don't think gender is relevant because both can have, male, female. There, yeah, which demographic variable minimum? Meaning. Okay, so weight, sir, is already the independent variable. I am asking which one else we should have. Date of birth. Okay, so not we cannot use date of birth, but yes, we can use age. Yes. So yes, height, age. Okay. Okay. So I have got few suggestions. So the you know, uh, And Pradeep sir is also saying development of brains or neurons or nutrition level. Okay, that can also be, if it can be measured at different points, it could be slightly complex, but yes, we can have it. A very simple solution to this, as many of you have rightly pointed out, is including age. And the moment age was included in this analysis, because height is also increasing because of age. So height is also fine, but more appropriate thing is age, because with age, a child's height and weight both are increasing naturally along with IQ. So the moment you include age in this analysis, the weight became statistically insignificant as it should have been, because there should not be any direct impact of weight on IQ. So this was my point. So we have to use multiple regression at times. So here I will run a quick one. So you can see it is India's stock index on few macroeconomic variables: GDP, inflation, interest rate, exchange rate, and money supply. The pattern is same, just I write fit, you can give any other name. Contains, fit is a variable which contains LM, linear model, then I index, dependent variable, title, followed by independent variables. And when in the earlier case, we only had one independent variable, when we are having more than one independent variable, we will add a plus sign in between. So if we add plus sign in between, you can see that we have a multiple regression equation of sorts here. And if I run this, sum up to summary and coefficients, then I will be getting the results. So you can see that we have obtained the results. So inflation, sorry, GDP, we saw in the graph also in the scatter that GDP was having good relationship with stock market. That is confirmed. That was in scatter plot, but it is confirmed in regression. You can see the probability GDP is having a significant Y, because it is less than 5%, even 1% would be 0.01. It is smaller than this. So the null hypothesis that said that this GDP has no impact or the beta coefficient is 0 is rejected strongly. So GDP has a significant positive impact on stock returns. And the other one that has came out significant is exchange rate. So if we see this again, it is less than 1%, highly significant, and the sign is negative, because exchange rate can have a negative impact, especially because India runs into current account deficit. India imports more and exports less. So exchange rate movement can adversely in India is a net importer. So for net importing countries, exchange rate is expected to negatively impact. Increase in exchange rate. Increase in exchange rate in mathematical value would mean depreciation of the domestic currency. So depreciation of the domestic currency benefits exporters, but if you are importing more, then it is a problem for you as an economy, like in case of India, because increase in value of $1 equal to 70 rupee, then $1 is equal to 80 rupee. So if exchange rate increases, then the rupee has depreciated. This will make imports more costly. So it will hurt business. It will cause inflation in the economy. It will reduce demand. But the simultaneous benefit to exporters would be limited, because we are importing more. We are more of a consumer economy. Some other countries like Germany, Japan, China, they are exporting more. US is also a consumer country. US also is runs into deficit, current account deficit. And again, now you can see that even though this was stationary data, R square is much higher. So, these kind of things are there, and you can run all of this. And Finally, we are already close to 11:30, so 1.5 hours has gone. And I have to also talk about the project. So you can, you can also see plot of the fit and ANOVA of ANOVA we can skip maybe. Plot of the fit. Yes. So, many of you would be interested in this kind of diagnostics. So I will be telling you many more extensions that you can use in regression. Now let me quickly cover up some graphs. So I am not explaining these. These are very simple. So counts for x2, and you can yourself see the result. Okay, why is it not working? So yes, bar simple bar chart. So this had two categories, 0 and 1, and it had equal size 100. So we are getting this simple bar. You have to only run the code. Again, you can see that everything else is fixed. The variable name counts you have to give. You have to again specify the data, and you have to dollar followed by the variable. Then stacked bar plot. You can see I have put two things here. So form size, small and large, followed by, okay, let me close this one and use the other data. Let me run it again. Yes. So in this variable, in this we have the coding. In fact, you have to, make an extra effort of doing reverse coding. Well, I mean, that is, converting the codes to, numbers when you're using softwares like SPSS. So for example, how you will frame a questionnaire. You will ask gender, male, female, and respondents in Google form or some other way will also see male, female. When you download that, it will also be in form of male, female. But for entering into SPSS, you have to change it to 01. So in fact, you are doing a more cumbersome process. If you use R, you can directly use that data which is there in form of male, female. For example, here we have used the data that is why I imported the Excel sheet of this data. I did not use the SPSS sheet. The Excel sheet, which you can easily download as responses to your Google form, we are getting this magazine and newspaper. Again, this is simple. I will show you how to add more, attributes to it. Now, the font size, large and small. This red one is for newspaper industry, and blue one is for magazine industry. This is a stacked bar plot. So this is the total large. Out of this red portion is those customers belonging to newspaper industry, and blue one are those belonging to the magazine industry. Yesterday we saw their cross tabulation also. Now this is one way of representing them, where the two categories are stacked on top of each other and a single bar has been divided. Otherwise, we can also represent them simultaneously. So for that, you can do it like this, green and blue. And how I am doing it, you can see it is nothing special. Counts, again, the name of the table. You have to use the table function, and then you provide the data variable variable data variable, and then you have to use this function bar plot counts. If you want to label x-axis, then you will say x label, then the label is font size, and color you have chosen red blue in the earlier one, and now you have taken green one blue. and so on. And for grouped bar plot, one thing to be noted is that you have to, there is an argument called beside. So if you don't put beside, like we did not put beside here, so it was stacked on top of each other. So to change it, you have to put beside. So if you put beside equal to true, then you will get a grouped bar plot like this. Similarly, for pie chart, it's very simple. I just run it. First, you have to use a table function for pie chart as we are using earlier also. Then you simply say pie my table. Then instead of my table, you can write table 1, table 2. It's fine. Again, for more than 2 also we can change it. Now, colleagues, this is what we wanted to cover using, so all these functions will be with you. I will be sharing this and will be mailing with you. So now I wanted to talk about, before I take up some queries, I wanted to talk about a couple of things. Okay, so I will take up some questions also. But let me first talk about the research project that you have to make out of this. So let me get a Word file. Yes. So dear participants, we have been, using R since 4 days. And as you know that, we have strict benchmarks. We are doing it in the MHRD, Teaching Learning Center. So we have strict benchmarks and we have to maintain rigorness in doing all the things. And since it is online mode, so it is even more important that we maintain the standards. Now, if this was offline mode, it was something else, but we have to give some sort of assessment, and we also have to provide grades. So for this topic, the past 4 days, including today, these 4 days, we have covered R, we have seen several applications. So you have to make a research project. If anybody has any queries, please write it in the question and answer. If you have any queries, please write it in the question and Q&A. And after I explain the research project part, I will be taking that up. So research project for sessions on management research using R. So in this assignment, or say, I say assignment research project. So in this, what you have to do is that you have to create a Word document and submit in form of a Word document. Submit the project as a Word doc comprising of Word doc, or if you are worried about formatting issues, then I can also allow PDF here. So Word doc or PDF, but it must comprise of the following. Number one, you have to state your research objective or question. So what and why you are doing the research and what is your purpose. You have to state that. Then you have to develop some hypothesis based on that. Then you have to describe your data set, sample, variables, time period, if any, Okay, then you have to provide statistical techniques that you are going to use. Then you have to provide R code for running it, for running the analysis. Then you have to provide the output of from R in form of tables and graphs. And finally, you have to provide interpretation, implications, and recommendations. So you do not have to write an article, you do not have to do any literature review, you do not have to provide any references. Just see what you want to do. So I gave you several examples. Just go through the recording, whether it is impact of any variable on the other, whether it is exploring relationship, whether it is testing that something differs over time, or any against differs across categories of any other variable. So all you need to do is to provide a brief research objective question. This should be minimum 2. And then accordingly develop hypothesis for them. So I stated hypothesis for most of the tests that we have done. You can also look up. Then you have to use data set. Now we have discussed and used several data sets. I think 5-6 data sets. You can use any other data set also, any other data set which is with you, or you can download fresh data from RBI, World Bank, IMF, any corporate database, CMIE, Proves, Bloomberg, anywhere you wish, money control, anything. Wherever you can get your data, you can use any existing data, but describe your data set, what it is about, what are sample, what are variables, what are time period, and frequency also, if it is there, sample size. Okay, then briefly mention what are the statistical techniques that you are going to apply on this data set for testing your hypothesis. Then you have to provide the R code for running the analysis. And then you have to provide output from R. And then you have to provide interpretations, implications, and recommendations. So I put it like objectives. So the first heading that we want is research objectives or research question. Second would be hypothesis. The third heading would be data. The fourth heading would be statistical techniques. The fifth would be R code. Then the final thing would be, second last would be results. And finally, results and discussion, if you want to briefly discuss the outcome also. And finally, it's interpretation, or we can leave it like this: interpretation, implications, and recommendations. This you have to submit, and minimum 2 objectives, and you have to apply minimum 2 tests. So you can accordingly decide how much you want to do it. And you have to submit it. Today is Wednesday, so you have to submit it by Sunday. at max, because by Sunday we will be winding up the program, so you have to submit by then. Okay, so before I open myself to questions, let me share one or two more important things. You can also use some R data sets that are available already, built-in data sets that are available in R. So all you need to do is to, look what are the data sets. I will just show you, and you can load it by writing like this: data brackets in quotation the data set name, and to see the data you can use this. So for example, if I write data uh, data, and if I write cars, yes, it is valid. And then if I write head cars, and if I run it, then you can see the cars data here. So there is a built-in data set in R, which is cars. So you can see this is the data, speed and distance, though it is very limited data. So you can also use any data set which is with you, or you collect a new data, or you use the data sets that I have provided, or you use the built-in data sets of R. And one more thing before I take up questions. So let me share the screen of my web browser. So, there are so many things. There are so many things that we did, and in this limited, because this requires a dedicated FTP of say 1 or 2 weeks to sufficiently cover the techniques. But the idea was to introduce you to these things. So, these things have been introduced in great detail with examples and explanations and codes and everything. Now, there must be several things that is coming to your mind, that how do I do this in R, how do I do that in R, and so on. So I tell you, for example, you want regression diagnostics in R. So you will see that there are several platforms, because all you need is codes, and there will be several platforms. For example, if I go here, you can see descriptive, frequency, correlation, t-test, non-parametric, multiple regression, regression diagnostics, ANOVA, MANOVA, power analysis. Again, graphs, the basics of graphs I explained. But, if you look into the codes here, for example, in bar charts, if you look into the codes, you can easily add more arguments. So, I created, were running short of time. We just have 5, 10, 12 minutes, and we have to also take up questions. This is the final session. So, I was running short, but you can, easily add up so many things here. You can add the labeling for X and Y axis. You can name things, and you can also see some videos, but it is better, to use the code and just get going, because you now know the basics of R. And you can convert them horizontally by using horizontal to true. Then regression assumptions and diagnostics in R, you can easily find code, and you can also find some packages relating to it. And this, I am telling you, beyond the uh, standard help. Otherwise, you can easily go to R Studio community, and there you will quickly get answers for your questions, as I said in the first session also. Because we have limited time, and everything is not possible to be covered, we need a dedicated 1 week or 2 week FTP. In fact, 2 weeks would be fine for rigorous training on this. How many of you would be interested in such a program if we organize a detailed 1 week or 2 week FTP solely on R? So you can either raise hand or you can write it in the chat, wherein we cover more such techniques in details. Yeah, and no, specifically which two test is you directly your call, and I will be obviously assignment doc will be shared with you. You have to choose. You have your researchers, your faculty members, you have to choose which test you want to use, which what you want to study. So probably my internet is slow because I'm also running a live video, but you can easily go to our studio community. And as I showed you on that day, partial correlation also, you can easily search for the, within few seconds, you will get the code and you can use it. So, okay, that's it for my side. And now I will be taking up the questions. So there is a question on how to decide the selection of parametric and non-parametric test. Victor, sir, I have already explained that parametric tests are preferred option if sample size is inadequate or assumptions are not being met or your data is categorical, then only you should use non-parametric test. And how to change the labels, you can easily see the options I just showed to you. Multicollinearity, you can check. I showed you the regression diagnostics. Can we use the data you have provided for us for this assignment? Sure, you can use the data that we have shared with you. Are these assignments case study related? You can take it in any form, but I have, to simplify things for you and to, not make it very cumbersome. I have avoided that you don't need to write the backgrounds. You don't need to write the background. You don't need to write things like literature review and introduction, because I want is that you straightforward come to objective hypothesis, describe your data, what techniques you are going to use, run it in R, present the analysis, and interpret it with implications and recommendations. That's it. Yes, you got the answer, sir. And when the assignment is to be submitted, Sunday, I told you, Sunday is maximum time because beyond that we cannot accept. Since this you also have today, we already are on Wednesday, and this will take some time. And you also have other sessions and other things, so we are giving till Sunday. But ideally, you should do it rather quickly. How do we share the R code? It is very simple, Anshika, ma'am. All you need to do is to go to our studio. For example, copy this code, and you go to your Word file and you paste this code. You paste your code here. You can see the code is visible. And you give proper heading that this is our code, this is result, this is interpretation. In fact, give 7 headings in your assignment, and this assignment will carry at least 30 marks, maybe 40 also, because today's session is the 4th session. So almost every day you were getting quizzes worth 7 to 10 marks. So between around 30 marks, this assignment will carry for 4 sessions. So you were getting 7 to 10 marks questions every day. So this will carry around 30 marks, maybe more. So the more better you present, it is good. You don't, Ramesh sir, you don't have to represent our output in PDF document. You have to copy, just like I showed, you have to copy our table or graph in a Word file, and then though I prefer that you, uh, share in Word file also, but if you are uncomfortable or you fear that the formatting will go vary, then you can share it in this in as save it as a PDF, but you can share it in Word file also. You can easily copy and paste the graph or the table in from our window, our console or plot segment to your Word file. Yes, I already told that you can use your data also, or you can collect new data also. You can use any prior data also which you have collected. It is entirely your call. I think organizers would be looking into this, that the in yesterday's and today's session are uploaded in the portal. I will also request. You don't have to send it to email. No, don't send the project on email. This is very important. You have to submit it as an assignment on the portal itself. Don't send it as an email. You have to submit it as an assignment on the portal itself. When the data is not normally distributed, then you can use non-parametric test. But if sample size is more than 30 or 50, then you can assume normality based on central limit theorem. Harsha, if RStudio is not opening in your laptop, then you can use R. Most of the things that we have done, including the code, including the output, including the tables, all of it will function in R. Just some of additional things don't work. So do it in R. R is compatible with all kinds of laptops and computers. And if anybody is coming up with this excuse that they do not have a laptop, then it is unfortunate. Please access it from your institution. Now we are in the 4th month since unlock. You can access it from any colleague, friend. You must be teaching somewhere, so you must be using a laptop. How can this be an excuse that no, somebody does not have a laptop? So please get it repaired. Service centers for computers and laptops I have seen are open since June. Please get it addressed. Otherwise, access institutional ID, or you can use someone else's laptop, or you can use cyber cafe or computer center. I have requested the organizers to upload sessions on the portal. No minimum sample size for the project. You can use the data, just describe the data, whatever you are using. But please keep it in mind that if the data set is limited, then sample size is limited, then you use non-parametric test, because then as normality assumption will be violated, especially if you have less than 30 sample size. Then can we make presentations in groups? Many questions will be arising. No, sir, this is individual assessment. You have to do individually, not in group. And for many things, actually, it seems like that there will be questions, but actually there won't be, because you have to exactly follow the commands. You have to only change the data sets. And that is why we are doing this, because uh, unless you practice this, please, dear faculty members, please understand that we are not doing a project to trouble you or to unnecessarily bother you. Please note that it is one thing to just see videos, but it is entirely different thing to do it yourself. And when you do it yourself, your learning and understanding of art will be considerably strengthened when you will do it yourself. So don't worry, don't panic, just get started. No, Arpita ma'am, I'm not asking for data also. I'm not asking for data. So you don't need to send data. If you want, you can provide it in the Word file or PDF file in the appendix, but I do not mandatorily need data. Yes, research problem has to be selected by you. Okay, you can contact if you have doubts, you can contact through email also, but I think you can post the queries on discussion forum. See, dear participants, I also have some other engagements. I will also be helping, but if you post your doubts on discussion forum, then please help each other. You are more than 200. Many of you would be comfortable with some things, many of you would be comfortable with other things. Many of you will be able to see the silly mistakes that your friends or colleagues are making, like small and capital letter, or wrongly typing the data set. That is why the code is not running. So for small queries, please use the discussion forum. Otherwise, mail is also there. I don't know about certificate. Please mail it to the organizers. Uh, the I think Smriti Ranjan ji, आपका your question is about for assignment. So for assignment, you will upload it on the portal itself. So like other assignments, I think you already have done some assignments. So the way it is, you have to upload it on the portal itself as a single Word file or single PDF file. रोहित जी 3-4 दिन तो ज़्यादा है अभी किसी और का कमेंट आया कि एक दिन में ही असाइनमेंट हो जाएगा और पोर्टल पे रेडी करवा दीजिए सबमिशन लिंक सो 3-4 दिन कम नहीं है और आप थोड़ा सा इस पे ट्राई करिए आप ये भी समझिए दैट वी ऑल्सो हैव टू इनकॉर्पोरेट योर ग्रेड्स so आप if when you will submit your assignment then it will be evaluated and please participants do not copy paste copy we will also mention it on the portal copy paste because there is a huge chance that some of you will try to copy paste it is very unethical and copy paste everyone because we do not know who has copied from whom so everything will be rejected summarily do not copy paste. So Rohit sir, I appreciate the intent. I will be able to see your intent. So whatever you do it honestly and do it yourself through your learning. So it will be good. And you also have a Saturday, Sunday coming up. No, there is no restriction on number of pages. So I am done with all questions. There are no more questions left. So thank you very, very much. I already told that there is no minimum sample size. Thank you very much. Please do not, take it as a challenge. Take it as a learning experience, dear professors, faculty members, research scholars, and it has been a pleasure to be associated with you for the past 4 days. If you want any other further sessions or associations in your institution also, you can contact me on personally. Otherwise, for queries related to this, please use the discussion forum and you can then, interact with them. So thank you very much. Thank you, everyone. And I would now request the host, Ramanujan College or Vibhas sir.
Yeah,
To,
Arnav, I'm here. I'm here.
yes,
Okay.
sir. So
Yeah.
that way that
I'm here. Thank you very much, Arnav, for giving this insightful lecture for the past 4 days. I think the participants have taken it in the right earnest and must be practicing, and they will remember you for have introduced R in their life. So
thank you.
whenever they are going to take up R, they will remember you. I'm sure about it, and I'm sure all the questions have been taken up, and the assignment is also given to the participants. So thank you, Dr. Arnav, for the insightful lectures throughout the time frame. And I'm sure it's not just the R thing which you have taught. You have also mentioned the methodology in detail. So, and the statistical tools, parametric, non-parametric, and resolved all the queries of the participants. So thank you very much, Dr. Anna, for this lecture. Thank you. Thank you.
Thank you.